Students, we are going to start a new topic, that is ray optics. Actually, what is optics? Optics is a branch of physics in which we study about light, properties of light, various instruments related to light, for example, telescope, microscope, etc., and the various properties exhibited by light. So, the branch of the physics in which we study about light, students, is called optics. Optics is basically classified into two parts. One is called ray optics and one is called wave optics. In ray optics, we study about mirrors, lens, optical instruments and various formulas related to them. Students, ray optics is also called geometrical optics. On the other side, in wave optics, we study about nature of light. What is the nature of light? It is of particle nature, it is of wave nature. And the various phenomena exhibited by light, like diffraction, interference, etc., polarization, etc. So, the optics has been classified into two parts: ray optics, also called geometrical optics; wave optics, that is also called physical optics. Now, as in the case of electricity, first of all, we have studied about charges. What is the origin? What is the base of the electricity? Base of the electricity is charge. Base of the magnetism is magnet. In the same way, the base of the optics is source of light. What is source of light? Students, that every device which produces light is called source of light. Sources of light has been classified into three categories. The very first is called thermal source. What is thermal source? Sources like sun, etc., they are called thermal source and they emit light of all the wavelength ranging from 4000 to 8000 angstrom. So, the very first is your thermal source. It produces light from 4000 to 8000 angstrom. The second one is gas discharge source. Such sources of light emits light of particular wavelength. They do not emit wavelength of all colors, they emit light of particular wavelength. For example, neon lamp. Neon lamp gives only red light. Sodium lamp gives only yellow color. So, they produce light only of certain wavelength. They are called gas discharge source. And the last one is luminescent sources. They emit visible light along with your ultraviolet radiation. So, dear students, sources of light are of three types. Number one, thermal source. Number two, gas discharge source. And the number three is luminescent source. The important one, the thermal source and the gas discharge sources, because thermal source emits light of all wavelength and gas discharge sources like neon lamp, sodium lamp, they are used in various experiments. Now, the very first topic of optics is reflection of light. What do you mean by reflection of light? Reflection is a very common word. Students, when light strikes on a polished surface, it bounces back in the same medium. When the light strikes on a polished surface, for example a mirror or any other polished surface, then the light is bounced back in the same medium and the phenomena is called reflection. So, reflection is the phenomena of bouncing back of ray of light in the same medium. When light traveling in a medium is incident on a smooth polished surface, it is sent back or you can bounce back into the same medium following certain laws. The phenomena is called reflection of light. Suppose this is a plane mirror, dear students. AO is the incident ray. At point O you draw a normal, then OB is called reflected. So when a ray of light strikes on a surface, then it bounces back in the same medium. AO is called incident ray and OB is called reflected ray. The angle which the incident ray makes with normal, that this angle is called what? Angle of incidence, and this angle is called angle of reflection. The angle which the incident ray makes with normal is called angle of incidence, and the reflected ray makes an angle with normal, that angle is called angle of reflection. Students, reflection of light take place under two laws. There are two important laws of reflection. The very first law states that the incident ray, reflected ray and normal, all the three lie in the same plane. You are drawing the diagram in your notebook. So, incident ray, reflected ray and normal all are in the same plane, that is plane of paper. In my case, incident ray, normal and reflected ray are in the plane of blackboard. So, the very first law is that incident ray, reflected ray and normal all lie in the same plane. The second law is that angle of incidence equals to angle of reflection. Angle of incidence equals to, students, angle of reflection. Angle of incidence is equal to angle of reflection. So, these are two important laws of reflection of light. Students, reflection is of two types. Basically, reflection is of two types. One is called regular reflection and one is called irregular reflection. I have written here, reflection takes place from a surface which is smooth and polished. The surface is smooth and polished. If the surface is smooth and polished, then the beam of incident ray as well as the beam of reflected ray both are parallel. All the rays of incident ray are parallel to each other. All the rays of reflected ray are parallel to each other. If incident rays and reflected rays remains parallel to each other, then the phenomena is called, students, regular reflection. But if the surface is irregular, it is polished, but not regular, not smooth, it is irregular. Then incident rays are parallel to each other, but the reflected rays are not parallel to each other. Such a reflection is called irregular reflection. The reflection in which the incident rays are parallel to each other, but the reflected rays are not parallel to each other, then the students' reflection is called irregular reflection. Students, there are certain important points about reflection through a plane mirror. In case of plane mirror, there are certain interesting points. Number one, in plane mirror, the image formed is of same size. You daily see your face, your image in the plane mirror at your home. You will observe the size of the image is same as that of object. It is virtual because you cannot take its image on the screen. Erect means सीधी, जैसे आप खड़े होते हैं बेटा इमेज वैसे ही बनती है. So in case of plane mirror, the image formed is of same size as that of object, erect and virtual. Also, in case of plane mirror, the image is formed behind the mirror as far as you are before the mirror. बेटा जितना आगे आप मिरर के खड़े हैं, इमेज आपकी उतना ही क्या बनती है बेटा, पीछे बनती है. One more important point I have not written here, lateral effect. Your right hand in the mirror will appear your left. Next is, if keeping the direction of incident ray fixed, suppose I keep the direction of incident ray fixed, turn the mirror by an angle theta, then the reflected ray will turn by angle 2 theta. Very important result for your competitive exams also. If keeping the angle of incident ray fixed, अगर हम incident ray को fix रखें and rotate the mirror through an angle theta, then the reflected ray will turn through an angle 2 theta. When an object is placed symmetrically between two plane mirrors, placed symmetrically means an object is placed on the angle bisector. If we place an object symmetrically between two mirrors, then number of images formed will be equal to 360 upon theta minus 1. What is the meaning of object placed symmetrically? Its meaning is that object is placed on angle bisector. Object is placed on angle bisector. Then number of images formed is equal to what? 360 upon theta minus 1. If object is not placed symmetrically, it is placed anywhere between the two mirrors inclined at an angle theta, then the number of images formed, students, will be equal to 360 upon theta. So this is what I have taught you in brief about plane mirrors, because now our main part will start from spherical mirrors. Students, now we are passing on to spherical mirrors. What are spherical mirrors? But a spherical mirror is a part of a transparent sphere, polished on one side. If you take a part of a transparent mirror and polish on one side, then it will behave like a spherical mirror. Now, suppose this is a spherical surface. Polish can be done either on the inner side, means side toward the center, or away from the center. Accordingly, mirrors are of two types. Number one is called convex mirror and number two concave. Mirrors are of two types, concave mirror and convex mirror. Students, this is a sphere. I have taken this part of the sphere and I have done polish on the outer side. When the polish is done on the outside, the reflection will take place from the inner side and that will be called concave mirror. So those mirrors in which polish is done on the outer side so that reflection takes place from the side towards center. Reflection takes place from the side towards center. Then students, it is called concave mirror. But if the polish is done on the inner side, in the second part I have shown the polish is done on the inner side, so that the reflection is taking place from the outer side, or you can say side away from the center, sees the center, then the mirror is called convex mirror. So in this way, my dear students, mirrors are of two types, convex mirror and concave. Now there are certain terms related to a mirror. Number one, center of curvature. The center of the sphere of which mirror is a part. The center of the sphere of which mirror is a part is called center of curvature. In the diagram it is shown by C. The center of the sphere of which mirror is a part is called, students, what? Center of curvature. In figure C is center of curvature. Second is radius of curvature. The radius of the sphere of which mirror is a part. Mirror is a part of this sphere, so its radius, that is cm dash or cm, will be called what? Radius of curvature. The radius of the sphere of which mirror is a part is called radius of curvature. The third term is what? Pole. Suppose, dear students, this is a mirror, then the center point of the mirror, or the center point of the reflecting surface is called pole. So P is pole. The next term is your principal axis. The line joining center of curvature with pole. The line joining center of curvature to pole is called principal axis. The line joining center of curvature to pole is called principal axis. And the next important term is, students, aperture. There are two types of aperture of a mirror. One is called linear aperture and one is called angular aperture. The diameter of the mirror is called linear aperture. This is your mirror. Mm dash is its diameter. So mm dash is called linear aperture. And the angle MCM dash subtended by the diameter at the center. Angle MCM dash subtended at the center of the sphere by the diameter mm dash is called what? Angular aperture. So aperture is of two types. One is called linear aperture and one is called angular aperture. Linear aperture means the diameter of the mirror. Angular aperture means the diameter subtended by the diameter at the center. Angle subtended by the diameter at the center is called angular aperture. So these are 5 important terms. Center of curvature means the center of the sphere of which mirror is a part is called center of curvature. Number 2, radius of curvature, the radius of the sphere of which mirror is a part. The radius of the sphere of which mirror is a part is called radius of curvature. Number 3, pole. The center point of the reflecting surface is called pole. The center point of the reflecting surface is called pole. The next is principal axis. The line joining the pole to center of curvature. बेटा पोल और सेंटर ऑफ कर्वेचर को मिलाने वाली जो लाइन होती है उसे हम क्या बोलते हैं? प्रिंसिपल एक्सिस. नंबर 5 is your aperture. Aperture is basically of two types. One is called linear aperture and one is called angular aperture. The diameter of the reflecting surface, suppose this is a reflecting surface, this is a diameter, then the diameter of the reflecting surface is called linear aperture. And this diameter subtends an angle at the center of the sphere, then that angle is called angular aperture. In the diagram shown to you, mm dash is linear aperture and angle MCM dash is called angular aperture. Now, we come to the sign conventions. In optics, the sign convention has very much importance because there are certain sign conventions which we shall use during the derivations, image formations, etc. There are certain sign conventions which are internationally accepted, which are number 1, all figures or ray diagrams are drawn with incident light travelling from left to right. Means when we shall draw the ray diagram, we shall take the light to be coming from left side. This is my left side. So I shall take the mirror on right side and the light is coming from left side. You can see here, this is the mirror, the right side, the light is coming from where? The light is coming from left side. This is the direction of incident light. So light is coming from left side. Second important point, all the measurements are done from pole of the mirror. बच्चों जितने भी मेजरमेंट होते हैं वो हमेशा मिरर के पोल से होते हैं. All the measurements are done from the pole of the mirror. Number 3, those measurements which are taken in the direction of propagation of light. Those measurements which are taken in the direction of propagation of light are positive. All measurements in the direction of propagation of light are taken positive. And the measurements in the direction opposite to propagation of light are taken negative. So this point is called what? Pole. And this is your what? So remember that all the measurements are made from pole. Measurements in the direction of propagation of light will be taken positive and measurements opposite to propagation of light are taken negative. Transverse distances means the distances along y-axis. Transverse distances above the principal axis are taken positive. Transfer distances above the principal axis are taken positive and the transfer distances below the principal axis are taken negative. जो मेजरमेंट बेटा प्रिंसिपल एक्सिस से ऊपर होंगे पॉजिटिव, जो मेजरमेंट्स प्रिंसिपल एक्सिस से नीचे होंगे नेगेटिव. तो दीज आर द सर्टेन साइन कन्वेंशंस व्हिच शैल फॉलो इन द फर्दर लेक्चर्स. Students, the word we are going to study is focus and focal. What do you mean by focus and focal? Rays coming parallel to principal axis, when it strikes a mirror, then either they converge to a point on principal axis or appears to diverge from a point on principal axis. So that point, dear students, is called focus, and the distance between pole and focus is called focal. Now the question is that, in which case, in which mirror, these rays will converge and in which mirror they will diverge. So in case of concave mirror, rays coming parallel to principal axis, after reflection from the mirror, actually converges to a point on principal axis. That point on principal axis is called the focus of the concave mirror. And the distance between pole of concave mirror and focus is called focal length. In case of convex mirror, rays coming parallel to principal axis, after reflection from the mirror, appears to diverge from a point, and the point is behind the mirror. That point is called focus, from where the ray appears to diverge. And the distance between pole and focus is called focal length of the convex mirror. So what is focal length? Students, in case of concave mirror, rays coming parallel to principal axis after reflection from mirror actually converges to a point on principal axis. Rays coming parallel to principal axis after reflection from the mirror actually converge. Converge means बेटा एक पॉइंट पर आकर मिलेगा. जब रेज के बीच का डिस्टेंस कम होता चला जाता है तो हम क्या कहते हैं बेटा, they are going to converge. So the rays actually converge to a point on the principal axis. Students, this point is called focus of concave mirror, F. The distance between pole of mirror, the distance between pole of mirror and focus is called focal length, F. So this distance from pole to focus, this distance is called what? Focal length. This distance. This distance is called focal. The focus of concave mirror is to the left side of pole mirror. But at this point is to the left and the measurements toward the left are negative. That's why the focal length of concave mirror is taken negative. The focus of concave mirror is to the left side of pole. So, its focal length, students, is taken what? Negative. In case of convex mirror, rays are coming parallel to principal axis. After reflection appears to diverge. Diverge means the distance between the rays is going to increase. After reflection, the distance between the rays is going to increase. Then the point from where they appear to diverge, that is called focus. In case of convex mirror, rays coming parallel to principal axis after reflection from mirror appears to diverge from a point on principal axis. Appears to diverge from a point on principal axis. Students, this point is called focus F of convex mirror. The distance बच्चों between pole and focus is called focal length. So in this case, what is the focal length? The distance between pole and focus is called focal length. So this distance बच्चों is called focal length. The focus of convex mirror is towards right side of pole. बच्चों, the focus of the concave mirror is towards the right side of the pole and the measurements towards right side are taken what? Positive. That's why the focal length of convex mirror is taken what? Positive. The focus of convex mirror is towards right side of pole. Therefore, focal length of students convex mirror is taken. So focal length of concave mirror negative, focal length convex mirror So dear students, remember very important term because basically the optics part starts from here only. That the rays coming parallel to principal axis after reflection either appears to diverge from a point in case of convex mirror or they actually converge to a point in case of concave mirror. The point is called focus. The distance between pole and focus, dear students, is called what? Focal length. The focus of concave mirror lies towards the left of the pole. That's why the focal length of concave mirror is taken negative. Always remember, in all the numericals, in all the derivations, the focal length of concave mirror will be taken negative and the focal length of convex mirror rise towards right. It is towards right, so it will always be taken positive.